Okay. Alright, so once again we are looking at derivatives involving natural logarithm. So this one is len. When you have a function involving a natural logarithm and you are asked to find the differentiation, how do you go about it? So let's take this one as an example. So we have our solution. We say find y dx if y equal to len into brackets sec x plus tan x. Alright, so the rule says that if you have y equal to say len of g of x, the derivative, which is y prime, is equal to g prime of x over g of x. Alright, so this is the rule. You have y equal to len g of x. So y prime is equal to g prime of x over g of x. So the most important thing over here is for you to be able to identify or extract your g of x. So by comparison, when you compare this one to the question given, we see that our g of x is equal to sec x plus tan x. Alright, so back to our question, we have our g of x be equal to sec x plus tan x. Okay, so you have to find g prime of x and divide it by g of x. So here our g prime of x is equal to d dx of the right hand side, which is sec x plus tan x. So here when you differentiate sec x, we have sec x tan x, and when you differentiate tan x, we are going to have plus sec square x. Alright, so we can see that sec x is common in both terms, so we can factorize sec x out over here. So our g prime of s is sec x multiplying tan x plus sec x. Alright, so we go back and write our dy dx. So our dy dx is equal to g prime of x over g of x. So what's our g prime of x? Our g prime of x is sec x tan x plus sec x. So write it over there. We have sec x tan x plus sec x all over g of x, which is sec x plus tan x. Alright, so we have over sec x plus tan x. So when you look at the numerator and the denominator, we have sec x multiplying tan x plus sec x. So this tan x plus sec x is the same thing as the denominator. Okay, tan x here, sec x here. Better, so you can write the denominator as tan x plus sec x. Alright, so that you can see it clearly. So you see that the denominator here will cancel the numerator, this one over here. So we have your dy dx to be equal to sec x times 1. Okay, when you cancel out, what will be left here is 1. So sec x times 1, and the same as sec x. So the derivative of len of sec x plus tan x is equal to sec x. Alright.